Okay, students, we're going to start going over your Edulastic review. I'll probably do about 30-minute increments, so however long it takes me to get through it, doing that at a time. Here we go. All right, number one, we have segment addition postulate. This AB, segment AB plus segment BC equals segment AC, segment addition postulate. Okay, so it says AB 4x plus 6, BC 7x plus 15. You add those together and it says it equals 120. So there's your equation. So you have 11x plus 21 equals 120. Subtract 21 across, you get 99. X equals 9. Now I go back and read the question. It doesn't want 9, doesn't want x. This is the length of segment AB. So I plug it in. 4 times 9 is 36, plus 6 is 42. Number 2, select the proper ways to name a line above. You have to have any 2 points in the line with a line symbol above. That's a segment symbol. That's a ray symbol. All of these are line symbols, so they're good to go right there. Okay, next. Classify them as parallel, perpendicular, or neither. Obviously, it's based off their slopes. Same slope, parallel. So we have parallel, negative reciprocal would be perpendicular, negative reciprocal, perpendicular, and that's a neither right there. Okay, perpendicular, negative reciprocal. Not just reciprocal, it has to be negative reciprocal. Parallel, same slope. Where's the slope? The coefficient of the x, your m. These are all written in slope-intercept form. Okay, angle 2 is 50 degrees. Angle 1 then has to be 130, a linear pair. You know the names of these as well. Angle 3 is 130, linear pair. Let's turn it to that. Angle 5 is 50 degrees. And you can go either by corresponding or you can go consecutive interior angles are supplementary or same side interior angles are supplementary. Remember, DCAS often likes consecutive interior angles. In angle 6 would be 130. And you can go by AEA, alternate exterior angle theorem, from here to here. You go by linear pair, right there. Or you can go by corresponding, right there. Or corresponding. Okay. So 130, 130, 50. Oh, A. That's what you're doing. A is 130. B is 130. C is 50, and D is 130. Okay. Name the opposite rays. Remember, opposite rays share a common endpoint, and they go in opposite directions. It's the only one you can have a common endpoint is A. So you have this ray, which is ray AC, and you have this ray, which is AT. Now, when you do rays, the endpoint must be above the A. So notice this endpoint is above C, it wipes that out. This endpoint's above A, this endpoint's above A. So AC and AT are correct right there. This endpoint is above C, can't be. This endpoint's above C, can't be. Okay. Complementary angles add up to 90 degrees. Okay. Supplementary are 1 and 7 supplementary if those two are parallel. They tell me like all pairs in the figure above that are supplementary. I'm hoping I missed something that said that L and M are parallel. Hopefully it said that these are parallel. Okay, if they did, then we have more answers. So then 1 and 7 are supplementary, same side interior angles are supplementary. 1 and 8 are not, those are alternate interior angles. 3 and 6 would be supplementary, and 4 and 7, no, those are congruent. So how do you know 3 and 6? Well, 3 and 8 are congruent, and 8 and 6 are supplementary because they form a linear pair. So I can say that those are supplementary. Drag and drop. Okay, so you're matching up. This is array. So you look for array, BA. Notice it endpoints above C. That's point C. This is plane A, B, C. Nope. Where's the other plane? Plane W. Remember, two ways to name a plane. Capital letter in the corner, it's not a point, or 3 non-collinear points. This is an angle, angle ABC. Right there. Segment AB. Right there. Line AB. Right there. Uh, line M. Right there. Remember, it can be either any 2 points on the line or a lowercase letter at one of the arrows. Here's line AB also. And this is plane ABC. Remember, it can't be ABD because they're collinear. It has to be 3 non-collinear points. And I've covered everything, yes. Okay. You have ray BA and ray BC. Okay, so if you only can use one, you're going to call this line AB then, and then this would be ray BA and ray BC to form that line, is what you're going to call that right there. Okay, which sequence of transformations reflects A to B? Reflection over the x-axis? No, it's not going to be over the x, we're going over the y-axis. Reflection over the y-axis and then 2 units down. So this is going to go 1, 2, 3, 1, 2, 3, and then 2 down. That would work. Yep. Okay. If I follow that, that will take it right onto it. Use angle addition postulate. That means this angle plus this angle adds to the whole angle. Angle addition postulate. Remember, we just did segment addition postulate to find x, and then find the measure of the indicated angle. So we have 12x plus 38, combining like terms there, equals 17x plus 8. Subtract that across, 5x. Subtract that across, 30, so x equals 6. Now, which angle do they want? Angle NBS. NBS, this angle right here, 12x minus 4. You have to identify the angle correctly. I saw some people that didn't identify the angle correctly. So 12 times 6 is 72, minus 4 is 68. Okay, name the intersection of plane BGM. Plane BGM is this one, and line EF, which is this one. So it intersects right there at point B. Okay, determine the value. Here we have vertical angle theorem. We know vertical angles are congruent, so set them equal each other. 3x plus 10 equals 40. Subtract the 10 across. 30x divided each other by 3, and you get 10. Select the correct angle pair for 3 and 5. 3 and 5 are called alternate exterior angles. Use tool, polygon tool. Obviously, I won't be able to do this once I put the points. reflected over the y-axis. So remember, I just count, here's the y-axis, just count and go across 1, 2, 3, because all reflectors are at 90 degrees to the line of reflection. Same distance also. 1, 2, 3, 1, 2, 3. So there's C prime. It's at -6, so it's going to be +6. B prime. It's at -6, so it's going to be +6. A prime. It's at -2, so it's going to be +2. D prime. And then I would reconnect them. Oops. Okay. Oops, right there. And right there. Okay, now you have to connect them in order A, B, A prime, B prime, C prime, D prime, and then back to A. Okay, angles A and B are pair of supplementary angles. That means they add to 180. So 2, oops, got to go back to writing. 2x plus 30 plus x equals 180. 3x equals 177. Divide each by 3, and you're going to get 59 degrees. X is 59. And then the measure of angle B. B is just x, that's 59 degrees. I'll always go back and reread the question. Find the values of 1 and 2 for the given figures and complete the table accordingly. In figure 1, since it's 82, we know this is 82. These are its corresponding angles. Then we have a linear pair, which makes this one 98 because they add to 180. So figure 1, angle 1, 98, angle 2, 82. Here, vertical angle theorem, so 64 degrees. And corresponding angles, 64 degrees. Oh, they already had that for you. 3, we have linear pair theorem, so they add to 180. And we have alternate interior angles from here to here, or I have consecutive interior angles, also called same side interior angles. They are supplementary. So angle 1 is 157, oops, and angle 2 is 23. We have a line in the slope-intercept form. Another line is perpendicular, so I should automatically write negative reciprocal, and passes through the point -6, 6. Choose the equation. So we need the slope. The parallel slope is 2, so the perpendicular slope is -1/2, the negative reciprocal. Okay, so we have the slope and a point, 6, -6. Okay, remember I said start in slope on point slope form, so that's going to be y plus 6 equals -1/2 quantity x minus 6, and now I can solve that for y and put it in slope-intercept form. So distribute y equals -1/2 x, that's plus 3, but then I'm minusing 6 across. So y equals -1/2 x minus 3. Now, you could have also just gone to this, since there's multiple choice. If you don't want to do all that work, you could sit there and say, okay, I know now it's the -1/2. So there's only one answer here of -1/2 on the slope, and I'd be done. Okay, now the other side -1/2. But I want to show you all the work in case it wasn't multiple choice. Line M has a slope of -3. Another line is parallel. Parallel means same slope. So it has to be -3. Plot the midpoint of the second blow. Okay, so this didn't get the picture, but I'll write down the midpoint formula. Midpoint formula, x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 divided by 2. So you average the x coordinates, average the y coordinates. Okay, select all the angles below that are congruent to angle 6. Okay, well that's going to be congruent. That's going to be congruent, alternate interior, vertical angle, alternate interior, corresponding for 14, or vertical angle there, corresponding there, also alternate interior from 6, or corresponding from 1. Okay, so all those are my congruent ones. So what do we have? Is 10 marked? No. Is 14 marked? Yes. Is 8 marked? Yes. Is 5 marked? No. Is 7 marked? No. Okay, there you go. Okay, these are parallel. What's the slope of L2? Well, that means I can just go and find it from this one to this one, since the parallel, same slope. So up how many? 1, 2, 3, 4, plus 4, plus 1. Remember, slope is change in y over change in x. So 4 over 1, which is 4. You leave it as 4. You simplify that fraction. You don't write 4 over 1. You write 4. They might mark you wrong. Find the measurements of the following angles. Well, angle 1, okay, well, so we have a line right here, for example. So these three angles, that's 150. That makes 30 degrees. Well, now we have a line also right there. It's 180 degrees. So 74 from 180 is 106. So 3 has to be 106. Okay, well, now we have another line right there. 136 from 180. 44 for angle 2. It's 44, not 42. And now we have another line right there, which makes these three 180. So that's 150 plus another 30 again. Of course, then you could see that these were vertical angles, so they have to be congruent as well. Okay, or you could have seen these are vertical angles here. You got that. And you could have seen that these are vertical angles here. You got that. Okay, so either way, through vertical angle theorem, or you just keep drawing these lines at 180 degrees as I did there. Select the proper ways to name the line above. So anything that's not a line, you wipe out automatically those two. Now, there's my line symbol on those three. As long as those 2 points are labeled there, it's good to go. Any 2 points, all those are labeled there. Determine the motion rule that reflects cardinal to LMOP. So what do? They reflect it over the y-axis. So which one reflects it over the y-axis? When you switch the x coordinate only, y stays the same. There's your rule for reflection over the y-axis. Little r for reflection. Which of the following is true for rigid motion? Okay, it's not larger, that'd be a dilation. Or rigid motions are reflections. Another word for a rigid motion, remember, isometry. So you gotta remember that, isometry. So you have your reflection, translation, rotation, glide reflection. Okay, they don't focus on the glide reflection. The preimage is smaller. No, it's a dilation. The preimage is the same, is in the same position. No, it doesn't have to be in the same position, but it does have the same measurements. All the angles must be, some corresponding angles must be congruent, and corresponding sides must be congruent. Match each geometric term with this definition. Okay. So let's see how far we can go down here. A section of a line starting at one point and extending infinitely in one direction. That is a ray. Two coplanar lines, remember coplanar means the same plane, whose point of intersection creates the vertex of a right angle. That'd be perpendicular lines. Okay, right angle, another word is perpendicular. An object of indeterminate size marking a location is space. That's a point. That's the definition of point. Two distinct coplanar lines, again in the plane, that do not intersect. That means that they were parallel. Remember the difference between parallel and skew. It's almost the same. In skew, it's not, it doesn't have to be coplanar. Okay, non-coplanar. If it's coplanar, it's parallel. If it's non-coplanar, it's skew. If it's in space. Set of all points connecting 2 points by the shortest means possible and extending infinitely in either direction. That sounds just like a line. Okay. Set of all points of fixed distance from a given point, that's a circle. Where's circle? Right there. Formed by two rays sharing a common endpoint, that's the definition of an angle. And the set of points marking the shortest distance between 2 points, that's a segment. Where's segment? Oh, I guess we've used them all. So that's just extra. Okay. Convert each equation to slope-intercept form, then determine if the lines are parallel, perpendicular, or neither. Slope-intercept equation. Subtract it across, divide by 2, and I get y equals negative x plus 5. Okay, subtract it across, and then divide each term by 4. Y equals negative x, minus 3. So that would be parallel, because they're the same slope of negative 1, and not the same y-intercepts. So the parallel. A and B are parallel lines. Choose all the geometric parts to be named from the diagram. There is more than one correct answer. Line EG, is this a line? No, it's not. It's a ray. Ray HI, choose all geometric that could be named from the diagram. Okay, there is a ray HI there. I would start here and go on here forever. Okay, so that's there. Segment EH, yes, that's there right there. Ray GE, that means it starts at G and goes through E forever. That is not there. And ray EG, yes, starts at E, goes through G forever. So there you go right there. Which of the following can be used to prove triangle ABC is congruent? Okay, we have our free point right there, reflexive property. So we have AAS, AAS. Rotate DF 270 degrees clockwise. So rotation of 270 equals rotation of negative 90. Negative 90 is clockwise, so it's going from quadrant 3. It's going to all end up in quadrant 2. Since all these 3 points are in quadrant 3, they all have to be in quadrant 2. Rotation of negative 90 degrees is a reflection over the y-axis first, which is the x-coordinate, to negative x, and then switch the y and the x. So that's a rotation of negative 90 degrees. So we can apply that. So if we said d prime, that right there is negative 5, negative 4. Write it down so you don't miss it. Now apply y, negative 4, negative x. So negative 4, 5 would be d prime. E prime, okay, that starts at negative 3, negative 4. So negative y is negative 4, negative x is 3. Negative 4, 3. There's E prime. And F prime, we have negative 2, negative 1. So y is negative 1 and negative x is 2. Negative 1, 2. Okay, and then we would go ahead and reconnect those. And there's your rotation of 270 degrees. So I could go 90, 180, 270 to bring it over there to quadrant 2. Remember, referring to that, let's go back to naming our quadrants. You got to make sure you know your quadrants. 1, 2, 3, and 4, written in Roman numerals. Okay, select the lines that are skew to AB. Okay, that means they're not going to be in the same plane. EF. EF is not, that's in the same plane. EH. EH, that would be skew. CG, that would be skew. AD. Nope, that's in the same plane, right there. Okay, that top plane. Okay, write an equation of line perpendicular, negative reciprocal. That passes through this. So parallel slope equals 2, perpendicular slope, negative reciprocal, negative 1/2, the point, 2, negative 5. Okay, they usually want it in slope-intercept form, but we'll start with point slope. Y plus 5 equals negative 1/2 x minus 2. Distribute negative 1/2 x plus 1 minus 5. So what, subtracting that 5 across, negative 1/2 x minus 4. And you put it in parentheses like this. Okay. Ron wants to build a ramp with a length of 14 feet, an angle of elevation of 26, the height degrees, the height of the ramp must be, so we're solving for x, SOHCAHTOA. First thing we know is the hypotenuse is the opposite the right angle. This is the opposite of 26, and this is the adjacent next to. So we need x and 14, which is O and H. Remember SOHCAHTOA, spelled like this. You got to know how to spell it. So we're using sine, the sine of 26 equals x over 14. Put over 1, cross multiply. X equals 14 sine 26. Now bring up the graphing calculator. Now don't forget, it's going to always start in radians on the DCAS. So you have to go to the mode, right? Clear it, go to mode and change it down to degrees. The first thing you should do whenever you're going to use that calculator. And then so I can quit. And we wanted 14 sine 26, right? Let me check. 14 sine 26, yes. Enter, and what did it say to round to? Rounding to the nearest tenth. Always go back and find it. Okay, so nearest tenth is 6.1. If you round incorrectly, you get no point. The length of the ramp, or the length of the base of the ramp, is about what? Okay, round to nearest tenth. We don't want to use that answer there, that 6.1, because that's a rounded answer. So now this time we're going to use cosine. Cosine of 26 equals y over 14. So y equals 14 cosine 26. We always use exact answers. 14 cosine 26, 12.6, because nearest tenth. Okay, I will go ahead and stop right there. Oh, it's like there's one more on this page. We'll go to the finish this page. I guess we'll finish these two on this page, and I'll stop and continue on. Exterior angle theorem. What's the exterior angle? Remember that equals the exterior angle equals the sum of the two remote interior angles, also called the sum of the two opposite interior angles. So that's 114, 121. Now you could have also found this third angle with the polygon triangle sum theorem, and then you use linear pair theorem to get the x as well if you forget the exterior angle theorem. Match angles the first column with the equivalent degree measure in the first row. Angle 3. Also for angle 4, it's like here, these are parallel. Notice this M is not parallel. So it's only this one and this one. Make sure you see that. Okay, so angle 9 has to be 65 degrees. Corresponding angles. Angle 3 is a linear pair, so that's 115. Angle 2 is also a linear pair, which they don't have here, but that'd be 115. Angle 10 is alternate interior, so angle 10 is 115. They don't have that one. Angle 11 is also 115, vertical angle theorem or linear pair. Number 9 is the same, it's also 65. Oops, let's just have one arc there because of vertical angle theorem. So number 9, 12 is 65. They don't have that there. Okay, so angle 8, that's a vertical angle, so it's 75. What else are we looking for? 6. That's a linear pair, so that's 105. And what else? I mean, angle 4. Angle 4. So that's a vertical angle, so that's 65. Okay. All right. So we'll stop there, and that's problems 1 through 34.